In this video, we are going to see about the open circuit test and short circuit test conducted in a transformer. There are two important tests conducted in a transformer. One is the open circuit test, the other one is the short circuit test. These two tests are called non-loading test because here we do not load the transformer. If you have a large transformer, you want to do some load test on this transformer, it will be a waste of energy because you need a large loading arrangement for the transformer and a large amount of power will be wasted. So to avoid that, these two tests are normally conducted. One is the open circuit test and the other one is the short circuit test. These two tests are conducted without loading the transformer. So these two tests will help you to do the performance analysis on the transformer without actually loading the transformer. So let us see about what is this open circuit test and short circuit test. Actually, using these two tests, we can find the parameters of the equivalent circuit. Already we have seen about the how to draw the equivalent circuit for the transformer. So you can refer the previous videos for that. So this is the equivalent circuit. The equivalent circuit parameters can be obtained from this two tests. Then you can find the voltage regulation as well as efficiency of the transformer. So overall we can get the performance analysis of the transformer by conducting these two tests. Let us see about the open circuit test. Open circuit test is also called as no load test. In a transformer, we know the windings, there will be two type of windings. One is the low voltage winding, another one is the high voltage winding because of the transformation ratio. Depending upon whether it is a step up transformer or step down transformer, the low voltage winding and high voltage winding position will be different. Now, in this case, this is the low voltage winding and here we have the high voltage winding. Normally, this high voltage side is kept open and the readings or the measurements are done on the low voltage side. So, in open circuit test, normally high voltage side is open. The reason is that if I use the meters, all these meters on the high voltage side, I may need a higher voltage range or a higher range meters will be required, which is only increases our cost. Sometimes it will be difficult to get a high range meter. So normally the meters are connected in the low voltage side and high voltage side is kept open. Let us see the equivalent circuit under open circuit condition. So here this side is open. So if this is open, there is no current in the secondary. So there is no voltage drop here. So you can leave this. If you see the primary current, since there is no secondary current, the primary current will be no load current, which is very small. So this drop will also be very small. So you can neglect this voltage drop. So if you neglect this voltage drop, then V1 will be equal to E1. So we are concerned only about this two parameter, that is the core loss components under open circuit condition. So the equivalent circuit we can reduce it like this. So RC and XM magnetizing reactance will be the focus under open circuit condition. So let us see what will be the procedure for the open circuit test. So we have seen that high voltage side should be kept open and the low voltage side we are connecting meters. So you need 3 meters for that. 1 voltmeter, 1 ammeter and 1 wattmeter. So the voltmeter will give you the measure applied voltage and this ammeter will give you the no load current and this wattmeter will give you the core loss. Okay, so this will give you the core loss. So once you connect the meters, the primary voltage, so how to so after connecting the meters, just here you can use an auto transformer to adjust the voltage. You increase the voltage till you get a rated voltage in the voltmeter. So suppose if it is 230 volt, you can bring it to 230 volt. Okay, so at that position, you find what will be the ammeter reading and what will be the wattmeter reading. So this is for an example. So it varies with each transformer. For example, if you are setting a 230 volt and you are getting a no load current of 1 amps, your wattmeter is reading some value. So it will be in watts. So you can say that voltmeter is giving you the applied voltage and ammeter is reading the no load current, and wattmeter will give you the core loss. So we know core loss is equal to, or power is equal to V1 I naught into cos phi naught. Okay. So here V1 we know, I naught also we got the reading. So from this we can find what is cos phi naught, which is actually the power factor. So from open circuit test, you can find some parameters for the equivalent circuit. So no load power factor cos phi naught is equal to PC by V1 I naught. So this is the wattmeter reading divided by voltmeter reading into ammeter reading. So this will give you the power factor. Then you can find, we know there are two currents here. I naught is dividing into two currents, IW and magnetizing current, IM and IW. So this IW is equal to I naught into cos phi naught, Im is equal to I naught into sin phi naught. So you will get these two currents. Now we can find what is RC and XM. So RC is equal to V1 divided by IW and XM is equal to V1 divided by Im, because V1 is the voltage across this branch divided by that particular current will give you the resistance value and reactance value. So from open circuit test, you can find the no load current, core losses, equivalent circuit parameters. So you will get the magnetizing reactance and core loss resistance. So all these data you can find from an open circuit test. Next we will see about short circuit test. In short circuit test, the low voltage side is shorted. So here it is the low voltage side. So directly short the low voltage side, and all the meters are connected in the high voltage side. So by this way, you can see that short circuit test means we are dealing with current. So here in high voltage side, current will be low. So we can use a high voltage side for measurement. So the procedure for short circuit test is that you are shorting the low voltage side and then connect the meters in the high voltage side. Again here you have to use an auto transformer. You adjust the voltage such that you get the short circuit current in the ammeter here. Okay. So voltmeter will give you the voltage required to circulate the short circuit current or the full load current. So ammeter will give you the short circuit current and wattmeter will give you the copper loss here. Okay. So in open circuit test, you got the core loss. From short circuit test, you will get the copper loss. So under short circuit test, this will be the equivalent circuit. So we have shorted the secondary. So the current will be a short circuit current, which will be a large current. So this drop R2 into XL drop cannot be neglected. Similarly, in the primary side also, the current is large. So you cannot neglect this drop also. So the voltage applied will be the voltage required to circulate full load current in the primary side. So we can do the calculations from this short circuit test. Copper loss is given by cos phi naught is equal to P copper divided by V1 ISC. And you can find the equivalent impedance. Z is equal to V by I. Equivalent resistance. Then equivalent reactance. So all these parameters can be found from the short circuit test. So from short circuit test, we will get the copper loss, equivalent circuit parameters, then resistance as well as reactance. So from open circuit test, we will get this information. From short circuit test, you can get this parameters. So let us summarize what we have seen so far about open circuit test and short circuit test. In open circuit test, the high voltage side is kept open. It is also called no load test. We can get the information about no load current and core losses. And equivalent circuit parameters, core loss resistance and magnetizing reactance can be found from the open circuit test. In case of short circuit test, the low voltage side is shorted. Here you can get the copper losses at full load condition. Then the equivalent circuit parameters, resistance and leakage reactance can be found from the short circuit test. Totally these two tests are called non-loading test because we are not actually loading the transformer. Without loading the transformer, we are able to get the parameters. So if you like the material, do subscribe to Read Electric Vehicle channel. Thank you.